KG-TV, Binghamton.
Hello, I'm Maria Lopez.
And I'm Buster the Parrot.
And welcome to Square One TV's Math Talk.
Maria, we got a call on the thing.
Then let's go to the phones and hear what Sammy from Sioux City says.
My big sister and I are playing a game.
Games are good, Sammy.
Baseball, football, basketball, luge?
Nope, another kind.
If it isn't baseball, football, basketball, or luge, I don't give a feather about it.
Chill, Buster. What kind of game, Sammy?
You spin a spinner and move your token.
Sounds like a real swell time.
Yeah, but between you and me and the lamppost, I think my sister is robbing me blind.
Cheating?
Big time.
Get my lawyer, we'll sue.
What's the spinner look like, Sammy?
It's got two colors, and when the pointer lands on the green, she gets to go, and when it lands on yellow, I get to go.
Sounds fair, sounds fair.
But she gets to go a lot more than me.
What you're talking about, Sammy, is probability, which just happens to be the topic of today's show. Watch this sketch from Square One TV.
Is it about probability?
Probably.
Hurry, hurry, hurry! Step right up, step right up! Round and round and round she spins, makes me dizzy, but somebody wins!
Excuse me, sir. Is this game fair?
Fair? My dear, you ask if it is fair? You hurt me to the quick. My game is unequivocally the fairest game at the fair!
Well, how does it work?
Simplicity itself, dear lady. I spin the spinner. If it lands on the yellow, I give you the sum of $1. If it is to land on the green, you give me the sum of $1.
Well, this sounds like it's a lot of fun.
It is. Your chances are even, Steven. It will either land on the yellow or on the green. If it lands on the yellow, you will experience the endless thrill of victory. If it lands on the green, you experience a temporary agony of defeat.
Wait a minute, lady. The game isn't fair.
Go away, kid. You bother me.
It's a ripoff.
Here's a nickel, little boy. Go pester the lions.
Wait a minute, he's a cute little boy.
Oh, yes, cute little spinner there. You know, I never met a little boy before I didn't like. Until now.
3/4 of the circle is green, and only 1/4 is yellow. That means if we spin it a lot, green will come up about 3 times more often than yellow. Your chances are not very good.
You told me this game was fair, mister.
Oh, it is fair, my dear lady. This little boy is obviously talking out of his beanie.
If that's so, why not let her take the green and you take the yellow?
I'm afraid that's impossible.
Why? Yeah, why?
Because I just closed for lunch. That's why.
What do you think, Sammy?
I think the kid was right. The game wasn't fair because 3/4 of the spinner was green and 1/4 was yellow. So the lady had a greater chance of losing than winning.
How do you think we can make the game more fair?
What if the spinner was half green and half yellow?
That's one way, Sammy. Now the probability of hitting green is 1/2 and yellow is 1/2.
1/2. Even chance, even chance.
Sammy, see if you can think of a way to make this game fair without changing the spinner.
What if the carnival guy has to pay more than $1 if the spinner lands on yellow?
That might work.
I'm sure there are other possibilities, too.
Other possibilities are probable.
Here's another game that uses probability, and you can play along with it. It's called But Who's Counting?
Who? Me. 1, 2, 3, 4, 5, 6.
Buster, why don't you go clean your cage?
Because it's dirty, that's why.
Did you tell the producers what I said about the job and my money?
Yes.
Well, what did they say?
They said, if you want to continue in the job, you'll have to continue to pay them the money.
Oh.
And now, time once again for America's favorite brain-teasing game show, But Who's Counting? And now let's meet America's favorite brain-less host, Monte Carlo.
Welcome to But Who's Counting, the game show that stretches your mind until it's an extra large. Let's meet today's contestants. Your name is?
Name.
That's what I asked you. Your name is?
Name.
Your name is name?
Yes, it is.
Do you have a first name, Miss Name?
What's in a?
What's in a name? Well, welcome to the show, and let's meet your opponent. Your name is?
Word.
Your last name is Word. Mm-hmm. Do you have a first name, Miss Word?
Oh, my.
Oh, my word. Oh, my word. You viewers at home, get pencil and paper ready and play along with us. You both know how to play the game, right? I'm going to spin this wheel with numbers 0 to 9 on it. Your job is to place each number that comes up on the place value holder, and the object of today's game is to create the largest possible odd 5-digit number. Now, in today's game, we're going to have a wild spin. After the 5th spin, you can choose one of your digits to be replaced by the number that comes up on the wheel. But remember, except for the wild spin, once you place your digits,
You can't change it.
here we go with the first number. Remember, we're looking for the largest possible odd 5-digit number, and our first number is coming up. It's an 8. An 8, the cardinal number between 7 and 9. 8. Here we go with the second digit. Remember, we're looking for the largest possible odd 5-digit number. 7. Place your 7s.
Hi, your offstage voice again. What's in a Name has guaranteed herself an odd number by placing the 7 in the ones place. She also put the 8 in a smart place.
1. It's an odd number, but it's not very large.
Oh My Word has guaranteed her number will be odd by placing the 1 in the ones place. This game is getting tense.
This game is getting tense. It's a 9, just what we all were hoping for, a 9. It's odd and it's large.
There is a 9, which is a big boost for Oh My, and she plopped it right where it belongs to give her the lead.
5. Place your 5. That's the 5th digit. All right, ladies, this is the moment. You can decide to replace one of your digits right now. If you want to, do it now.
What should Word and Name do with their replacement spin? Let's see where we are.
Well, Name is behind. If she replaces her 1, the probability of getting a larger number is good, because 8 of the numbers on the spinner are bigger than 1.
That's true. But would that make her number large enough to win?
I see what you mean.
What digit should she replace?
Digit, digit, digit. And what about Word? What should she do?
Why don't you figure out what they should do?
Okay.
I'll wait here.
Here we go with a wild spin.
It's replacement time, and everything What's in a Name has going for her is riding on this replacement spin. She needs a 9 to beat the best number Oh My Word could have.
6. That's a 6. Place your 6, and let's see who has the larger odd number. Miss Name.
69,517.
69,517. Let's see how your opponent did. Miss Word.
I've got the whopper. 98,761.
98,761. That is an odd number, and that is larger than your opponent's. Congratulations, you're today's champ. Very well done. Well, that's all the time we have for today. To our runner-up goes a terrific prize, a year's supply of gas-operated socks, and to our winner goes a brand new left shoe for those days when you just have to hop. Well, that's it for today. And remember, till next time, may the math be with you. Bye-bye. Have a good one.
Name didn't win, but we knew she probably wouldn't.
She had to get a 9 to win, and the probability of that was only 1 in 10.
1/10, 1/10. Long shot, long shot.
I'm beginning to understand probability a little.
I heard you talking, Sammy.
Uh-oh.
Who's that?
Susie.
My sister's on the other phone.
Susie the cheater?
I don't cheat.
Yeah, right.
I don't. Not at Penny's.
Pennies?
Yeah, see, sometimes we flip pennies and guess whether heads or tails will come up.
You've got a whiz-bang of a sibling rivalry going there, don't you, Sam?
Flipping coins, eh? Yet another game involving probability. Watch this.
Now, I will tell you, I have here a fair coin. A fair coin. Now, what that means is that the probability of getting heads on each flip is 1/2, and the probability of getting tails is also 1/2. Now, the chart, which Beverly is showing you here, shows my results after 8 flips. I got heads, tails, heads, tails, heads, tails, heads, and then tails. Here's the question. Which is more likely on my next flip? Heads or tails? That's the question for the challenge round. Now, to win the challenge round, you must be correct about both players, so let's find out what they think. Cynthia.
Well, I see an obvious pattern here. The coin is probably going to land heads since the last flip was tails. I say heads is more likely.
Cynthia thinks heads is more likely. Chris.
Well, yeah, there is an obvious head-tail pattern, but I think it's very unlikely that this pattern will continue, and I think that tails is more likely.
Chris thinks tails. Cynthia thinks heads. Think about it and write down your decisions. Which is more likely on my next flip? All right, for the challenge round and possibly the game, you've written down and locked in your decisions. Adine.
Well, this time I changed my answer. This time I think Cynthia is telling the truth and Chris is bluffing.
You think Cynthia is telling the truth and Chris is bluffing. All right. Cynthia.
Third time in a row, I agree with him. I think that Chris is bluffing and Cynthia is telling the truth.
Cynthia is telling the truth and Chris is bluffing. All right, let's find out how you did. Now, you're going to have to be correct about both. Will the truth tellers please stand? They were both bluffing, and let me explain to you why. The probability of the coin landing heads or tails is independent of what happened on previous flips. Okay, it doesn't matter what happened before, no matter how many times you flip it. So neither heads nor tails is more likely than the other. The probability of each is 1/2.
Cynthia and Chris are liars. Cynthia and Chris are liars.
Well, they were both wrong. Cynthia said heads was more likely, and Chris said tails was. But actually, heads and tails were equally likely.
But that heads, tails was such a nice pattern.
Yeah.
And patterns are important in math, but this one doesn't tell us anything because when you flip a coin, the chance of getting heads is the same as getting tails. The chances are equal on every flip.
Really? Equal on every flip?
Right. Even if you flipped a fair coin 100 times and it came up heads every time, which is not very likely, the probability of getting heads on the next flip would still be 1/2. Same for tails.
So a coin has no memory, right?
Right.
But I do, and I just remembered a home movie.
About what?
A coin flip, my brother Louis Duane, and probability.
I love home movies.
Heads or tails?
Tails. Oops! Heads or tails. Brought to you by Probability, another division of mathematics. It's more than just arithmetic.
Well, Buster, I don't know. It's not very likely that your brother would fly away with the coin.
Yeah, you don't know my brother.
Oh?
He's a thief.
Oh, you're silly. Thanks for your call, Susie and Sammy from Sioux City.
Thank you for your help. Come on, Susie, let's go flip a penny.
Great idea.
Those youngsters sure know how to have a keen time.
Come again soon to Square One TV's Math Talk. Will you be here, Buster?
A possibility is probable.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG-TV, Binghamton.
He's not here. Now's my chance. Hello, this is Square One TV's Math Talk, and you're on the air with Buster, the superstar. Today, I'll talk...
Superstar? Buster, what's going on and who locked me in my dressing room?
Uh-oh.
Today, we're supposed to do a show about graphs. Do you know anything about graphs?
They make it easier to understand stuff.
What stuff?
Well, numbers.
Among other things, graphs help us communicate more easily. There are several kinds of graphs. Bar graphs, circle graphs, line graphs. They all help us see information. Do you get it, Mr. Superstar?
No, but I'm getting a superstar headache.
Then watch this sketch from Square One and call me in the morning.
I have acquired a headache. The sensation is not unlike the playing of 3 kettle drums in a compact car. Boomba, 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 boom, boom, boom. You get the idea.
It sounds like a data headache.
I have acquired a data headache.
Mm-hmm. Too much information and no way to organize it.
Corporate profits are numbers to be reckoned with, I know, but every once in a while they make me very, very ill.
Will you try a line graph?
A line graph?
Mm-hmm. A quick, easy way to organize and display data.
I will try it.
Line graph. Just one of the many tables, charts, and graphs available to you anytime, anywhere. When in doubt, chart it out.
The pounding is gone. I'm overjoyed. By putting information on a line graph, I can clearly see how my company's profits change over time.
Will you use line graphs in the future?
I certainly will. And thank you for your help. Now, what can you suggest for ring around the collar?
That line graph showed her that over a period of time, her company's sales were going up for a while.
And down for a while.
And then up again. You could get the same story from looking at the sales numbers, but this line graph makes it easier to see.
I see.
We have a call. Hello, you're on Math Talk.
This is Sylvia Parakeet. Is Buster the super jerk there?
May I say what the call is in reference to?
That bird brain stood me up. We were supposed to break a cracker at Munchie's Trattoria last night, and he didn't show.
I'm sure there's some perfectly reasonable explanation.
Sylvia, I love you.
Ha!
Sylvia, I'm sure Buster does give you all his love.
I get all his love, all 100%.
100%? Greed is such an ugly word.
Sylvia, watch this song from Square One. Pay particular attention to the bass drum.
If he's putting me on, he'll think he's a bass drum.
Just think of the bass drum as a circle graph. I'm sure that will help you understand.
Thanks, Maria. I owe ya.
I heard that.
So how come just when everything was going so good, you gotta bring up this commitment thing? You say you ain't getting 100% of my love, and I admit it's true. But long before today, I gave most of it away, so there's hardly any left for you. I'm saving 4% for a dear, dear friend who's lying sick in bed, and 8% for a pal of mine who fell and hit her head.
So you see, when you add up all these slices, you get 100% of his love.
Sylvia, I feel the same way.
You love the New York football Giants 10%. You only love me 8%.
They had a better record.
They had an easier schedule. And how can you love your bike?
What's not to love? The chain doesn't slip anymore, and I just got the training wheels off.
Be gentle, Sylvia.
You love a crummy jacket 18%.
Yeah, well, it needs cleaning. But, Sylvia, you still get a whopping 8% of my love.
And here's something from me to you, Buster. A whopping 100% of my good buys.
Here's a sketch with another sort of graph. It's called a bar graph.
Okay, what? I can't see. I go, but she meant everything.
Oh, Buster, come here. Put your beak on my shoulder and don't look back.
She was so smart.
Take a look at this graph here. Now, you will notice that this graph shows the daily high and low temperatures over the course of a week. Now, as you can see, the blue bars represent the high temperatures, and the red bars represent the low temperatures. Here's the question. Which day had the lowest high temperature? Which day had the lowest high temperature? Okay, there's the question. And now for some answers. Chris.
Monday, because it had the lowest temperature of the week, and the high temperature was pretty low, too.
Chris says Monday. Beverly.
Oh, come on, you guys. Look at the graph. It's obvious. The lowest high temperature was Wednesday.
All right, Beverly says Wednesday had the lowest high temperature. Chris says Monday. Think about it. Which day had the lowest high temperature? Chris, you've had time to write down and lock in your decisions.
I think that Beverly is telling the truth and that Chris is bluffing.
You believe that Beverly is telling the truth. She said Wednesday, and Chris is bluffing. He said Monday. Jeanette.
Me too. I think Beverly is telling the truth and Chris is bluffing.
You also believe that Beverly is telling the truth and Chris is bluffing. Okay. For 100 points. Let's see how you did. Will the truth tellers please stand?
Yes.
Beverly is telling the truth and Chris is bluffing. Very interesting. Beverly, could you please explain?
Yeah, I'd be glad to. You don't need to look at the red bars at all, just the blue ones. The shortest blue bar is on Wednesday.
Did you like that, Buster?
I only hope Sylvia was watching.
This next sketch uses a bar chart to show the snowfall in a given area. It's a way real weather forecasters might do it.
I've always wanted to meet a real weather forecaster.
What for?
You're absolutely right.
We interrupt this program to bring you the latest news in the world of meteorology. Weather with weatherman Brainerd Lamont, already in progress.
Now, back to the weather. Hey, are we having snow here or what? Overnight here at Square One TV, we received an average of 7.5 inches of snow right here on the roof of our building. So kids, get out your sleds and come on over. What an icy July. Now, maybe you're wondering how we figure out that snow average. Well, here's the guy that figures it out for us. A real precipitation nut. Love him to death. Our station security guard, Lester Bodrick. Lester?
May I see your ID, please?
Lester, you know who I am.
Doesn't matter. If you don't have the ID, you can't stay on the premises.
Lester, we're on the air.
Don't make me use the cuffs.
Okay, Lester. There you go.
A little slower, please. Thank you. Please wear it at all times.
And now, Lester, about the snow.
Oh, yeah. Well, see, what I did was I went up on the rooftop of the station, and I took my official security guard yardstick, batteries not included, and I measured the snow in 6 different places.
Now, why 6?
Well, you may think that the snow falls equally all over the rooftop, but in actuality, it is not the same depth all over the roof because the wind blows it all around. Now, you see, by measuring the depth of snow in 6 different places, I can find an average depth of snow. Ask me how I do that.
How do you do that?
Whoa, what an excellent question. Lights, please. Thank you, I love you too. Oh, you're sensational, baby. Now, here's some data that I've collected from my wonderful, fabulous, incredible trip up on the roof. Hit it, guys. Love you. Submitted for your approval. Just a little joke there, folks. Hey, at point A, I measured 11 inches of snow.
At point B, 7 inches. On the way to the other side of the roof, I slipped, but hey, no problem. Didn't hurt one bit. I got my act together. And I measured 12 inches at point C. And only 1 inch at point D. Over at the center of the roof, a bunch of guys were having a snowball fight. Piece o' cake. Talked my way over to the middle. I measured 3 inches of snow. Then at the flagpole, my country, 'tis of thee. Interpretive version, folks. 11 inches of snow. Lights up. I love you. Please.
Hey, yes, so I add up the numbers here. For a total of 45, I divide that by the number of times I measured the depth of the snow, 6. 45 divided by 6 gives us an average depth of 0.75 inches.
No, that can't be right.
Huh?
That's only 3/4 of an inch. All your readings were more than 1 inch, so how can your average be less than 1 inch?
Oh, yes, you're absolutely right. I read it incorrectly. It's 7.5 inches.
That sounds more likely. The average depth is 7.5 inches.
That's correct, and that average tells you how deep the snow would be if it was spread out evenly all across the roof.
Huh.
There, you see? 7.5 inches.
Oh, that's fascinating.
Yes.
Oh, we just received this note from the station manager.
Oh.
While you were up on the roof, someone stole all the typewriters from the newsroom.
Oh, dear. Well, I'd better get on that case right away. Thank you. Goodbye.
Yes, well, thank you, Lester.
Yes, and don't forget to sign out. Sign out. Goodbye.
Well, that's what's happening in the world of weather. Have a great day. Whoever you are.
His first measurement was 11 inches.
His second was 7 inches. Third was 12 inches.
Fourth was 1 inch. Fifth was 3 inches.
And sixth was 11 inches.
That's a total of 45 inches. Spread over the 6 places,
Each would have 7.5 inches.
that would have been the depth of the snow if it had fallen evenly.
Thanks for showing me a little bit about graphs.
Buster, I'm sorry about Sylvia.
Yeah, well, I wonder if I ought to maybe up it to 9% of my love.
See us again on Math Talk.
Hello, Sylvia. 10%, but that's my final offer.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG-TV, Binghamton.
Hello, I'm Maria Lopez, and welcome to Square One TV's Math Talk.
Hello, I'm Maria Lopez, and welcome to Square One TV's Math Talk.
I just said that. You're repetitive.
I'm Buster the Parrot, and there's nothing wrong with repetition. Nothing wrong with repetition. Nothing wrong with...
Today's show is about polls and surveys.
Polls and surveys are ways to find out what a lot of people think by asking questions of just some of them. And the ones you ask stand for the whole group, right?
I'm impressed.
Yeah.
Let's all watch this sketch from Square One TV. Have you ever watched the show?
Since I was an egg.
Oh.
That's a yolk.
This sketch is about a politician who takes a survey because he wants to know if he's going to win an election.
An election? You mean where everybody votes and the one who gets the most wins?
That's right.
Why not just wait?
Wait for what?
Till they vote.
Because he wants to know now.
He wants to predict the future?
In a way. Wouldn't you like to know what will happen in the future?
Why must you put me through these ethical gymnastics?
You'll be a stronger parrot for having done them.
Feel my muscle.
Watch this sketch.
Then will you feel my muscle?
The only thing we have to fear is losing our cool. No, that'll never do. Come in.
Excuse me, where can I find Mr. Zagorski?
I'm Zagorski. Here, have a button.
Oh, thank you. I have the information you wanted.
You must be the pollster.
At your service. Now, you wanted me to ask the voters how they were going to vote, right?
Right, to take a poll.
Right, well, of course, I couldn't ask all the voters how they were going to vote because that would take all month. So I asked a small sample, a percentage of the voters.
Which may give us an indication of how all the voters might vote.
Exactly. And you'll be glad to know, sir, that according to my poll, you received 90% of the votes.
90%?
90%!
I don't believe it. I'm going to be the next mayor. Wait, now, exactly who did you poll?
Well, I had to start somewhere. So, I phoned everybody in town whose last name begins with a Z.
You what?
Well, it's a very small sample because you see, sir, there are only 20 people in this town whose last name begin with a Z.
And they're all my relatives. Papa Zagorski, Grandma Zagorski, the Zagorski cousins.
That explains it.
Explains what?
Well, why you're so popular. 4 people told me to send you their love, and 1 person told me to give you a big kiss.
Mom.
Well, I guess my sample wasn't very representative of the entire group of voters, because I don't think the town is as crazy about you as your family.
Your poll doesn't tell us anything. You're going to have to do another one.
You're right, and I'm going to get right on it.
Good.
So tell me, who are you going to vote for?
You can't ask me.
That's right, because you're you. I'm sorry, Mr. Zagorski. I was just trying to get a head start. Bye.
That poll was wrongo because he only asked people whose last name started with Z who they would vote for.
Some people had no chance of being asked. Unfair.
Let's see what he does next. Will everyone have an equal chance of being chosen in this new poll?
I hope so. If you can't trust a pollster, in whom can your trust be placed?
The only thing we have to fear is acid indigestion. No, too harsh, maybe. Come in.
Mr. Zagorski, I finished the new poll.
And?
You've got nothing to worry about. 95% of the people I question are going to vote for you.
95%? It's a landslide.
That's right. Da-da-da. Congratulations, Mr. Mayor, Mayor.
Here, have a button. Now, who did you poll this time?
Well, I was walking by the post office, so I decided to go in and ask all the people that work there.
Did you know that I was a mailman for 15 years?
Oh, really?
And that the people at the post office are my nearest and dearest friends?
Oh, wow, that explains it.
Explains what?
Well, when I walked in and mentioned your name, everyone started singing, "For he's a jolly good fellow, for he's a jolly," you know that song?
Okay. Once again, your sample isn't very representative of the entire group of voters.
Oh.
You need to find a random sample, one in which everyone has the same chance of being chosen.
You mean I should just talk to people that are going down the street?
Or call the name at the top of each page of the telephone book. That way you'll get a better sample.
Got it.
Good. Now, I have a speech to write. I'll see you later.
Okay, bye.
Wait a minute. Wait 1 minute. How would you finish this sentence?
Okay.
The only thing we have to fear is...
spiders.
Spiders. Not bad.
I know they freak me out. Bye.
That post office sample wasn't representative either.
No, they only asked his friends. It's a jip.
Let's see how this next poll goes.
Come in.
Hey, Mr. Z, I'm back.
Good to see you. I see you have a button.
Oh, always, always.
Now, tell me, did you do a new poll?
Yes, I did.
And was it a random sample?
Yes, it was. I just opened the phone book and put my finger on a number without looking, and I did it 20 times.
Now, that's a better sample. Tell me, what were the results?
You haven't got a prayer.
What? Oh, no.
Yeah, your history, you're dead meat, Mr. Z. Here are the figures. 80% of the people I called are going to vote for your opponent. That's 16. While 15% of the people are undecided. That's 3 people. And 5% of the people I called are going to vote for you. But that's only if it rains that day and she can't go sailing. Oh, and your mother says hi.
This is terrible. Well, it means I'll just have to work harder, shake more hands, kiss more babies, make more speeches.
I wouldn't make any more speeches if I were you, Mr. Z. That last speech was...
Well, the people loved it. Well, the ones who stayed to the end, anyway. Both of them liked it a lot. Of course, they were my sisters, and one of them went to sleep.
Yeah, she's only 3. So.
Well, this is terrible. It was a terrible speech.
Well, let me put it this way, Mr. Z. The only thing you have to fear is, making speeches. Bye.
Now, that was a proper survey.
Poor Zagurski, poor Zagurski,
Yeah, but sometimes you don't get the results you hoped for.
poor Zagurski.
Now, our next piece is about a different kind of survey. This one's about coffee breaks, when workers take a short rest from their jobs and have a cup of coffee. Watch this sketch.
I don't think I should.
Why?
Coffee sketches keep me awake.
The power and the freedom of mathematics is a flaming sword. It shall be our duty to use it justly. Hold it high, guard it well. Math Court, where common sense prevails. Math Court, with the Honorable Judge Sandra Day O'Crater presiding.
Order! Order! This is not a kangaroo court, so get that kangaroo out of this court immediately.
The kangaroo is a marsupial.
I didn't order marsup. I ordered marsalad. Just who are you, anyway?
I'm the prosecuting attorney.
Then prosecute somebody.
Yes, so learned hand. Today we have a case before us that could rock this nation to its very foundation. The defendant is attempting to overthrow one of the basic tenets of democracy. He has interfered with a free and open election.
Quiet, quiet, or I'll bring the kangaroo back. So, you've tampered with an election result, have you?
No, Your Honor, I am innocent. I am as pure as a driven snow.
When I was your age, we didn't pamper snow by driving it. We made it walk. Well, that's the trouble with today's weather. We baby it.
Oh, I couldn't agree with you more, Your Honor.
In that case, I reverse my decision. Make your case.
The alleged perpetrator is the president of a company called Ingots Matter.
You make the ingots?
No, we make the matter.
What's the matter?
Nothing. What's the matter with you?
If Your Honor, please.
Your Honor does please. Your Honor also thank yous. Your Honor is a very polite judge.
Recently, a free and open election was held at the company, and it was decided by the voters to do away with coffee breaks.
No more coffee breaks? Good. Who needs broken coffee?
The vote had to carry by a majority.
The voters all had to be majors?
No, Your Honor, a majority means more than half.
And did it carry?
Yes, it did, Your Honor, but...
It did indeed. Bailiff, if you would be so kind.
100% of the voters voted to do away with coffee breaks?
That is exactly the case, Your Honor. But when the alleged president of the company saw the results of the election, he overturned their wishes.
Well, that's not very nice. Shame on you.
This manipulative manager, this conniving cur, this would-be dastardly demigod would dash the will of his workforce and continue the coffee breaks against their wishes.
Then I find you guilty of interfering with democracy. I sentence you to 300 years of community service. Next case.
Well, don't I get a chance to defend myself?
Oh, all right, you little baby, but don't throw yourself on the mercy of the court. I just had it clean.
Very well. Thank you, Your Honor. I employ 150 people at Ingots Matter.
I object, Your Honor, on the grounds that this information is irrelevant, immaterial, and most of all, I don't like the defendant's tie.
Overruled. I'll deal with you later.
I'll bring the cards.
As I was saying, Your Honor, I employ 150 people at Ingots Matter. Ask the prosecuting attorney how many people voted.
We already know that. 100%.
You're beautiful when you're astute.
No, Your Honor, only 13 people voted. 137 didn't.
What's that you say? 13 voted?
That's right, Your Honor. But you are quite right when you say that of those 13 voters, 100% voted against having coffee breaks.
If the other 137 people didn't bother to vote, they will just have to abide by the decision of those who did.
No, Your Honor. I overruled this vote because I found it highly questionable. The vote was held at 10:30 a.m.
What do you mean? What are you getting at? Who cares what time the vote was held?
Let me guess. At 10:30 a.m., all the other employees were on their coffee break. Am I right?
Exactly the case, Your Honor. The sample was totally biased.
It was?
Certainly. The people who were on their coffee break probably would have voted to continue to have coffee breaks. The election was held when they couldn't vote. It was rigged. It was unfair.
That's right. It was unfair.
The only fair thing to do is to hold another election when everyone is present, which is exactly what I intend to do as soon as I get out of court.
I guess I shouldn't have brought this case before the court.
I'll be the judge of that, and I judge you to be right. Don't you ever think before you prosecute?
I don't think so.
Case dismissed. You may leave.
And so, once again, justice has prevailed in Math Court.
And take that voiceover with you.
What did you think of that survey, Buster?
I think it was unfair, just like the owner said it was.
The main thing about polls and surveys like these is to make sure everybody in the group you're surveying has an equal chance of being included.
It's the Democratic way, Maria.
Buster, have you noticed something strange about today's show?
I didn't get enough FaceTime, if that's what you mean.
No, it's that we haven't had any phone calls. I wonder why.
Uh-oh.
What? Uh-oh.
Some featherhead left the phone off the hook.
You're a big bird to admit it.
I didn't admit it.
Did you do it?
Yeah.
See you next time on Math Talk.
I'll be here, too. I'll be the one in the feathers. And the, tar.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG-TV, Binghamton.
Hello, and welcome to Square One TV's Math Talk. I'm Maria Lopez, and my associate is... babbling. Buster the Parrot, what are you doing?
Yeah, we don't have any phone calls, so I'm reading fan mail.
Fan mail?
From the kids.
Oh.
They like me better.
Don't be vain. What did they say?
Well, these people want to start a Buster the Parrot Club.
Oh?
They even sent a picture of the club they want to use. And this young lady wants a photograph with my claw print.
That's sweet.
And this guy wants to know about conducting.
Conducting? Conducting what? Orchestras, electricity, trolley cars?
Conducting surveys.
Aha! The very thing today's show is about. Doing a survey.
A survey like an oivey?
No. A survey is a way to find out what a lot of people think by asking questions of just some of them.
Will it make me a better bird?
It could, but doing a survey can be tricky.
Isn't a survey just asking questions?
Yes, but you have to be careful when you choose the people you're going to ask. Get it?
No. Show me an example, or else.
Or else what?
I'll molt.
Tough guy. All right. This sketch is all about a big, important candy family.
A family made out of candy. Do they share?
I don't know, but they are concerned that not enough people are buying the gumdrops they make.
They could adopt me. I love gumdrops.
Here's a gumdrop. Eat it.
Thank you, Maria. It seems to have stuck my beak shut.
Yes, one of its finest qualities.
But I can't talk.
But you can watch.
The eyes could be next.
Callus, the story of the family that baby ruthlessly took over the candy industry in Texas. The story of J.B. Jellybean Callus and his worthless low-down relatives. Let's join a few of the scuzzy ones. J.B. Jellybean Callus, his wife Sue Becky, and their daughter Becky Sue have just arrived in Grasshopper Gulch, Texas. It's J.B.'s hometown and site of a strange lack of interest in Callus Candy Company's new line of gumdrops.
JB, I don't understand why we had to come here to Grasshopper Gulch.
Now, Sue Becky, I'm gonna go over this just one more time for you. You see this? This here's a sales chart. It's a sales chart for Callus Candy gumdrops. It's semi-irritating.
But why, Daddy? I thought the sale of Callus Candy gumdrops was just peachy.
Oh, really? They are?
Why, sure. More than 60% of the people in Houston and Waco are buying your gumdrops, Daddy, and almost the same amount in Dallas, San Antonio, and Austin. Oh, El Paso's a little down, but Daddy, you know El Paso.
Uh-huh. Well, why don't you just keep a-going, darling dearest, and look at my very own hometown of Grasshopper Gulch. Would you just look at those sales? It's disgusting, and it makes me feel like a failure.
I think you're overreacting.
Well, if they let me have a 6-gun on this show, I'd show you overreacting.
Daddy, please remember your heart condition.
Oh, your daddy doesn't have a heart, child. That's a lump of coal.
Well, thank you, darling. Now, I think we better get to the bottom of this here candy mystery. Becky Sue, why don't you fan out and take a survey?
A survey?
That's right. I want you to interview the fine citizens of Grasshopper Gulch and find out why my gumdrops aren't selling.
Well, Daddy, what do we do first?
Well, I guess we better just freeze frame and let that flannel mouth announcer talk.
Well, what will the town's good people tell the Callus family about their candy? Will they get some good information, or will the Calluses have to take matters into their own hands? Stay tuned for the next exasperating episode of Callus.
Are you excited, Buster? They're about to do a survey.
Yeah, to find out what?
To find out what the town of Grasshopper Gulch thinks of JB's gumdrops and why they aren't buying them.
Who cares why? They just don't sell.
But if they can figure out why they don't sell, maybe they can make some adjustments and up their sales.
Up your sales! Up your sales! Parrot overboard.
Just watch.
You give a lot of orders for a non-parrot.
Daddy, Mama, I think I know why the gumdrops aren't selling here.
Well, now you just catch your breath, darling, and you fill us in.
What did you find out, dear?
Well, I went over to the women's sewing circle meeting over there. I asked every member what they thought of Callus Candy gumdrops.
Well, how many were there?
Well, I made some marks on my pad for everybody I talked to.
Well, now, how many is that?
14.
Now, why don't you tell us what those women of the sewing circle said?
Well, Daddy, you're not gonna like this, but 5 of them said that they didn't like gumdrops, period. The other 9 said they didn't like the shape of the box. Seeing as they were members of a sewing circle, they said that they'd prefer a round box.
Well, now, that is the silliest thing I've ever heard. But if that's what the citizens of Grasshopper Gulch want, well, then that's what I'll give them. Far be it from me to deny the public.
Well, now, just hold your rocking horse, J.B. You can't base your opinions on what 14 members of the sewing circle said.
And why not?
They were telling the truth, weren't they?
Well, I guess they were, but they're only 14 people. They're not representative of town opinion. The women's sewing circle is not what you call a fair sample. There weren't any men and there weren't any children, were there, Becky Sue?
No, ma'am.
JB, how many people are in this town?
Oh, about 1,000, I reckon.
Well, you can't make a decision about 1,000 people based on the opinion of 14 members of the women's sewing circle.
Well, now, darling, what am I supposed to do? Interview every single person in this whole gall darn town?
I know. We'll spread out across town and interview every second person we meet for the next 2 hours. That'll give us a good sample of town opinion, say about 150 people or so. Then we'll compare our notes and study the data.
Well, now, that is a good idea.
Now do we know? Now do we know?
No, we don't, because they only asked people in the sewing circle. No one else had a chance. Now they're going to pick a sample that will represent the whole population.
Your eyes sparkle when you're talking smart.
Buster.
I know.
Watch.
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 3 watches, and I still don't know what time it is.
We interviewed 150 people, and 8% of them said they like them just fine. Say they're better than black-eyed peas on New Year's.
Why, look, Daddy. That's just about the same percentage as the one you got on this chart you had made.
Fine, darling, but what about the other 92%?
Well, 6% said they didn't like the shape of the box. 12% said they didn't like the taste. 6% said they didn't like Callus Candy gumdrops because they didn't stick to the movie screen when you threw them like a good gumdrop should. 10% said they wouldn't eat anything made by you, JB. And 58% said they didn't like them because they're just too sweet and sugary.
You know, I'm not sure I follow you.
Well, read it and weep. Is it clear now?
I'll say it's clear. A picture speaks louder than 1,000 words. It seems to me that the principal reason that the good citizens of Grasshopper Gulch do not want to eat my gumdrops is because they're too sugary.
Right.
But that just doesn't make sense to me. Now, why would these people in Grasshopper Gulch be different than the rest of the state of Texas?
Well, now, I thought about that too, JB. So I went to the public library, and I found this book.
A Short History of Grasshopper Gulch.
Read the sentence I put the paper clip next to on page 168.
168. All right, here it is. Grasshopper Gulch was founded in 1828 by a group of 12 dentists who were frustrated by too many cavities back east.
Read on.
Over the years, they taught the principles of good oral hygiene to their descendants. To this day, the citizens of Grasshopper Gulch remain a people who take very good care of their teeth. Well, that's real interesting, Sue Becky, and it explains my pearly white smile, but
Well, don't you see, JB? 58% of the people in Grasshopper Gulch who don't buy your gumdrops say it's because they're too sweet. That's because they're afraid all that sugar's gonna ruin the teeth.
So you see, Daddy, all you have to do is come up with a brand of gumdrops that's sugar-free. And I bet lots of people will buy them, even outside of Grasshopper Gulch.
well, I've got just the slogan. Sugar-free gumdrops? Sure, we got them. They'll stick to your teeth, but they sure won't rot them.
Oh, that is truly horrible, JB.
Thank you, darling. You make me blush.
That was a good survey because it represented the whole town. Everybody had the same chance of being asked.
Good survey, good survey.
Look at this. 58% don't like the candy because it's too sweet.
That's more than half the town.
But if they make a sugar-free candy, those folks might love it.
And if they did, and you add them to the 8% who already like them,
You've got a whopping 66%.
plus the 12% who just don't like them, just might like them.
Could be. It's worth a shot.
Bang!
What was that?
The aforementioned shot.
Here's another bit from Square One TV about surveys.
Don't those people do anything else?
Take me out to the ball game. Oh, wow, this is so great. Hi, sports fans. Get up, get up. It's the 7th inning stretch. Of course, I've got nothing to stretch. Except my mind. And maybe yours. It's a heck of a ball game, huh? These days, though, the game sometimes has more statistics than strikeouts or stolen bases. Hey, don't get me wrong. Oh, gosh, I love stats. No, really. But sometimes an announcer will hit you with a stat, like how many runs a player with green eyes scores on rainy nights under the lights on artificial turf when he's got a Band-Aid on his thumb and his mother is watching. Give me a break, please. But I did hear a stat today that got me thinking. It was about southpaws. Southpaws, you know, left-handed pitchers. My team, the Expos, has a bunch of them. Of the 10 pitchers, 5 are southpaws. So, okay, I thought. Which hand do they use to sign those humongous paychecks? Whoops! So, okay, I thought. If half of the Expos pitchers are lefties, does that mean that half of the world's population is left-handed? I checked it out. Sure, plenty of you are lefties, but more of you are righties. Way more!
Turns out the Expos pitchers aren't really representative of the whole population.
Only about 1 in 10 humans are left-handed. That's 10%. Doesn't sound like much, but just because the righties are a big majority, it doesn't mean the left-handed minority is peanuts. No way! You see, the world population is about, 5.3 billion. I knew that. 10% of that is 530 million. So that makes 530 million lefties. Whoa! That's more than twice the population of the United States. Hey, you can find out if the stats for your class fit the big picture. Take a survey. Figure out the percentage of lefties. Now remember, the bigger the sample, the
Closer the percentage will probably be to the world average.
A real small group would not be very likely to match the 10% world average.
Take a look at the last 4 presidents. 3 of them, Ford, Reagan, Bush, are southpaws. That's 75% of the sample. Those guys may lean to the right, but they're all left-handed. Oh, time to get back to the game, now that we've stretched our minds. Hey, we've got a lefty at the plate. Know who batted lefty? The Babe! Here's the pitch. The batter swings, hits a long fly ball deep down the left field line. That ball is out of here! Yeah! Right on! I mean, yeah! Left on!
Here's an idea. Do a survey in your class. Find out how many people are right-handed and how many are left-handed, and see how you compare to the U.S. population.
A classroom survey. What a swell time we'll have.
Now you guys out there do the survey, and join us again real soon on Square One TV's
Math Talk. I love the way I say that.
Buster, why do you suppose there are so many left-handed baseball pitchers?
Because a Port Sider's delivery has him breaking off pitches into a right-hand batter's fist, yet disallows a left-hand slugger to dig in and pull a ball because it is breaking away from his wheelhouse.
Who are you?
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG-TV Binghamton.
I'm Maria Lopez of Square One TV's Math Talk, and this is my friend... Buster, why are you hiding?
Today's subjects got me twitchy. Making inferences.
Yeah?
Making inferences? I didn't even make my bed.
Making inferences isn't like making your bed. It means drawing reasonable conclusions.
Reasonable. Oh, good. Making my bed is unreasonable.
Making inferences is gathering information about what has happened in the past and looking at it carefully to infer or figure out what might happen in the future. Now, did you make your bed yesterday?
No, I was busy. Then there was the earthquake.
And the day before that?
No, see, because I had to water the dog.
And the day before that?
No.
And that?
No.
And that?
No.
Then I infer, based on your history of bed making,
Yeah?
you won't make it tomorrow either. Watch this from Square One TV. It might help you understand.
Maria, you won't mention this inference to my mom, will you?
Oh, hello, my fellow citizens. Be with you in a moment. As your next president. Aye, facts, head full. Hey, I'll run my speech by you. As your next president, I will do my utmost to help people learn to program VCRs. For too long, this great nation has been left on pause. It's time to move this country into fast forward, and I am just the computer glitch, president to do it. Let's fast forward through this next part. It's boring.
Ask not what Fax Headful can do for you. Ask what you can do for Fax Headful. By the way, the director is Danielle. Video for all.
Thank you. What'd you think, huh? Problem is, I haven't got much of a chance. You know why? I just heard a statistic on the news. Get this. 8 out of the last 10 presidential elections were won by the taller candidate. It's a fact. So it's easy to see who our next president will be. The tall guy! 8 out of the 10 winners were the taller candidates. So it seems you've got an 80% chance of winning if you're the taller candidate. Where does that leave me? Fax Headful. I'm not tall. Even measured diagonally, I'm short. If 8 out of the last 10 winners were the taller guys, gosh, little old me only has a 2 in 10 chance of winning. Hey, wait a minute. Did I say 8 of the last 10 presidential elections went to the taller guy? Well, what about all of the presidential elections? Sure! That might give us a different picture. Quick check of my data, my fellow citizens. Shows that when you look at all 51 elections, height was not a significant factor. That means that presidents are elected for a lot of different reasons that don't have to do with how tall they are.
Whoever came up with that first statistic didn't use a big enough sample.
Oh, statistics can be tricky that way. So, there is hope for me. Fax Headful. Tall. Short. No, user-friendly. That's what counts. Me, the next president of... Thank you. Thank you. They really like me.
Hello, Teresa from Toledo. You're on Math Talk.
Didn't Fax make a mistake? He only looked at the last 10 elections, where 8 of the winners were taller, and then concluded he couldn't win.
Yes, but then he corrected himself by looking at all the presidential candidates and figured he could win.
So it's not just getting the statistics, but how you use them.
Exactly.
I think I'll run for president.
I won't vote for you until you start making your bed.
I'll put her down as undecided.
Here's another piece from Square One about making inferences. It's from...
I'll handle it. A presidential candidate needs oratorical practice. Let's join Square One Challenge. Already in progress. How is that?
Keep your day job.
This is my day job.
She has brought with her an unusual spinner. You'll notice that one region of the spinner is green, 2 are blue, and the other 3 are red. Now, I spun this spinner 600 times, and I kept a record of the color that turned up each time. The question is, which of these graphs is more likely to show my results, A or B? I spun it 600 times. Which graph will show my results? Which is more likely to show my results, A or B? Arthur.
Only one part is green, so green won't show up very often at all. I pick B.
Arthur says B. Is he telling the truth or is he bluffing? Louisa.
All 3 colors ought to come up about the same number of times. I pick A.
Louisa says A. Truth or bluff? Think about it. An unusual spinner here. We spun it 600 times. Which graph, A or B, is more likely to show the results? And you've written down and locked in your decisions, Shilpa.
I say Arthur is telling the truth and Louisa is bluffing.
Arthur telling the truth with B and Louisa bluffing with graph A. All right, thank you. Jonathan?
I say Louisa is telling the truth and Arthur is telling the truth.
You believe they are both telling the truth. All right, that's an option. Once again, let's find out how you did in the challenge round. It's worth 200 points. You must be correct about both. Truth tellers, please stand. Arthur was telling the truth. Louisa was bluffing. Let's find out why. Arthur.
Well, each wedge is as likely to turn up, but one of the 6 wedges is green, so it's likely that green would show up about 1/6 of the time. 2 wedges are blue, so blue would show up about 2/6 of the time. And half of the wedges are red, so red would show up about half the time. Graph A shows all 3 colors at about 200. That's not impossible, but not as likely as getting close to 100, 200, 300, as in graph B.
Did you notice, my little presidential parrot pal, that blue was twice as likely as green on that spinner?
Oh, sure. And red was 3 times as likely as green.
Very good.
Even a modest parrot such as I can make that inference from the spinning of that spinner.
Buster?
Yeah?
Why don't you make your bed?
Don't we have another sketch from Square One about making inferences?
Yes. Would you like to introduce it too?
Certainly. I'm a possible presidential parrot.
I know.
Ahem. My fine feathered friends, it is with a heavy heart that I come
The
before you
old
this
clock on the wall says it's time for the David Numberman Show.
From New York, it's Late Afternoon with David Numberman. The show with a rating solo, they rounded it down to 0. And now prepare yourselves for a guy who will always pull a number on you, David Numberman.
Oh, we are off to a flying start, aren't we?
We are?
Look, listen, Paul, I gotta ask you a question. In all the years you've been on this show, have you, learned anything about math?
I certainly have, Dave. In fact, I've been doing some work with graphs recently, and I've developed a theory which I'd love to discuss with you. It has to do with sports, Dave.
Sports? Oh, well, perhaps you'd like to mention it to our next guest, Reggie Perfecta.
Reggie Perfecta is going to be on our show. Perfecto! He is just the man to appreciate the work I've been doing. I have a very important prediction to make, Dave.
Really? So do I.
Oh, really?
Yes, I predict that your prediction will be wrong.
Oh, ye talk show hosts of little faith. Why don't we hear what Reggie has to say, huh?
Well, he's waiting in the wings. Let's bring him on, ladies and gentlemen, America's foremost sports commentator, Reggie Perfecta. Sorry about that, Reg. You know, Flo and Mo were here yesterday.
Flo and Mo?
Yeah, you haven't seen them? The tap dancing seals?
No, that was the day before, Dave. Yesterday was Snort.
Oh, that's right. Snort the pig was here yesterday. Yeah. Hey, listen, that is one brainy porker, Reg. He sat there rooting for the square of any number I gave him, and of course, when I gave him 49, he got very excited. But enough about that. Hey, it's great to have you back on the show, Reggie.
It's always an experience being here with you, Dave.
Yeah. Hey, you know what? People say, I want to get this straight here because I like to get to the bottom of things, that you look down on the world of sports. Now, is that true?
From my vantage point high up in the press box, I suppose I do.
Oh, which would be the reason, of course, that people look up to you.
I think it would be fair to say that people do.
Yeah, well, you know, Paul does. Paul, come on over here. Paul Safer, ladies and gentlemen. Paul has some kind of theory he'd like to discuss with you.
Mr. Perfecta, I've looked forward to meeting you so much. I've listened to you for years. I think you are a giant in sports journalism.
Why, thank you.
Mr. Perfecta, I think I've made an important breakthrough in using mathematics to predict future records in sports.
Sounds intriguing.
What would you say, Mr. Perfecta, is the greatest moment in track and field history?
Undoubtedly, when Roger Bannister from that sceptered Isle of England broke the 4-minute mile back in 1954.
Right. Well, Mr. Perfecta, what would you say if I told you that I had figured out exactly when someone would run the mile in 3 minutes?
I'd say that was impossible.
Not if you use mathematics. I'll show you. Dave, I need the, Lou.
What?
Lou.
Paul, you should have gone before the show.
No, not the Lou. Lou!
Oh, well, go ahead, just call him. It's okay.
No, he only comes when you call him.
Get out of here. Lou, could you please come out here for just a second? Come on out. Here we go.
Hey, Lou. These points represent the world's records for running the mile since 1865. This descending line is the mean. Here's Roger Bannister breaking 4 minutes, and here's Steve Cram at 3 minutes, 46.32 seconds. He's the current record holder. Now, as you know, human beings just get faster and faster. And you know, Mr. Perfecta, as well as you, Dave, that we can use graphs to predict trends in the future. So, if I just extend this line like this, you'll see that it intersects the 3-minute line in the year 2110. That's when someone will run the mile in 3 minutes for the very first time.
Wow, how about that?
Nobody can run that fast.
But you can't argue with math. It's right here on Lou's belly.
But, Paul, you can't just plug in numbers without considering what they represent. According to your projection, if I continue this line even further, like this, some guy around the year 2600 will run the mile in no time at all. After that, people will be clocking in negative times. They'd finish the race before it even started.
Yeah, well, speaking of no time at all.
But it could happen.
You have to allow for the limits of human endurance.
You certainly do.
At some point, humans just won't get any faster.
Yeah, well, let's pause.
Common sense suggests that it is highly improbable that a human being will ever run a mile in 3 minutes.
But if it does happen, it'll be around the year 2110, folks. Guaranteed. Set your watch by it.
Which is about when we'll get our next break at this rate. Listen, we'll be right back after these messages because these guys are...
Buster, what do you think was wrong with Paul's inference?
His hair.
Come on.
Oh, all right. The human factor.
Right. There are limits to how fast a human can run.
Fish gotta swim, birds gotta fly, humans can run till they strain a thigh.
Maybe someday someone will break the 3-minute mile.
I don't think so.
I don't either, but nevertheless, no one will ever run a mile in 0 seconds or less.
So we can make inferences from information that we have, but we need to use common sense.
I couldn't have said it better.
Don't be too hard on yourself.
Hello, you're on Math Talk.
Hello? Let me talk to Bernard, now.
Bernard?
Yeah?
Bernard?
Hi, Mom.
Bernard?
Did you see the show today, Mommy?
Yes, I did.
Did you learn anything?
Yes, and I'm making an inference. If you don't make your bed right now, you'll be grounded for the next 7 to 10 years, plus 120 days of community parenting.
Good old Mumsy.
At least one of us will see you next time on Math Talk. Bernard?
Put a cork in it, Marie.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG-TV, Binghamton.
I'm Maria Lopez, and welcome to Square One TV's Math Talk.
I'm Buster the Parrot, and here's the Flash Gang. Maria told me backstage today's show is only average.
Buster, I didn't say this was an average show. I said it was a show about averages.
Average show about averages, same diff.
Do you know what average means?
Yeah, it's not too good, not too bad. It's right in the middle.
Buster, we're talking about averages of numbers. Why don't people call in when I need them?
Numbers?
Buster, watch this sketch from Square One TV. It's about averages.
Does it star Facts Head Cold?
Full. Full. Facts head full. Head full.
You ought to do something about that cold.
Hey there! It's me again, your buddy. Facts head full. You know what's great about this show? No commercial breaks. Of course, that means no downtime for you to run out and grab something to eat. You humanoids do that a lot. Eat, I mean. And not just during the commercials either. I mean, you eat all the time. Sure, it's just 3 meals a day, you know, plus some snacking, right? But you do it your whole life long. Meal after meal, snack after snack. It adds up. Breakfast, lunch, supper, snack, snack, snack. Breakfast, lunch, supper, snack, snack, snack. Breakfast, lunch, supper, snack, snack, snack. Wow. For one thing, each year, you eat an average of 7 pounds of ketchup. Whoa, that'll add up to about 500 pounds over an average lifetime. And you'll eat nearly 7,000 hot dogs in your lifetime. 7,000! A lot of dogs. Hold the chili. Of course, I wouldn't know. I'm a slender, computer-enhanced videographic circuit anomaly who watches his figure. Whoa! Hey! Wise guy. I wasn't programmed to have an appetite, except an appetite for facts, so I go for the juicy ones. Stats that help me understand you humanoids. That's what's so great about averages. They give me the big picture. Take donuts. Each American on average eats 63 dozen per year. That's 756 donuts. About 2 donuts a day per person. But wait a finger-licking minute here. Come on, everybody in the country doesn't down 2 donuts a day every day of the year? Junior, no going out to play until you eat your 2 donuts today.
Yes, Mama. Chop, chop.
That's a good boy. No. We're talking average here. You probably don't scarf down 2 a day every day. But if you eat less, then other people out there have to be eating more. Somebody's packing those sinkers away to bring up the average and make up for the donuts you aren't eating. Yum.
Buster, we have a call on the math phone.
For joy, for joy.
Bernie from Bismarck, you're on Math Talk.
Sounds like Facts Head Cold again.
No, that was my bull moose, Howard. I'm in 4H.
Oh. Well, do you have a question from Bismarck? Not you, Howard.
Yes, and it has to do with the fact that I hate donuts. I don't eat them ever.
You wonder why no one invites you to parties?
Okay, so you don't eat donuts. So?
So, how does Facts include me in the average and say I eat 2 donuts every day when I never eat donuts?
I see where you're coming from.
Me too. North Dakota.
Think of it this way. If there were a certain amount of something, anything, and it were distributed equally to everyone, the amount each person got would be the average.
Are you calling me average?
Here, look at this chart. One person ate 0 donuts.
That would be I. I don't eat donuts, ever.
You've made that point abundantly clear, Bernie.
But say last year, I ate 300 donuts. Buster ate 100 donuts, and Howard ate 400 donuts. The average among the 4 of us would be 200 donuts apiece, because 800 divided among the 4 of us is 200.
The average, in this case, is the number of donuts we'd eat if we all ate the same amount.
I still don't like donuts.
How do you feel about milk of magnesia?
Here's another way of thinking about averages. It's from a quiz show called Square One Challenge.
Already in progress.
This is a video question, so pay close attention to your monitor. Here we have the starting 5 players for the Minnesota Munchkins. Wonderful basketball team out of Minnesota now. You'll see that 4 of the players stand 50 inches tall, while the star center stands 60 inches tall. Here's the question. What is the average height of the starting team? 4 of the players are 50 inches tall, The center is 60 inches tall. What is the average height of the starting team? What do you think, Beverly?
Hey, it's simple. The average is halfway between the shortest and the tallest, so the average height is 55 inches.
Beverly says 55 inches. Think about that. Louisa?
I don't think so. Most of the players are 50 inches tall, so the average has to be closer to 50. I say 52 inches.
All right, Louisa says 52 inches. Beverly says 55 inches. Think about it and write down your decisions. The average height of the starting team. Teddy, what did you decide?
I believe Beverly is bluffing and Louisa is telling the truth.
You believe that Beverly, who said 55 inches, is bluffing, and Louisa, who said 52 inches, is telling the truth. We shall see. Loretta?
I think that Beverly is bluffing and that Louisa is telling the truth.
You also believe that Beverly is bluffing and Louisa is telling the truth. For the second question, let's find out. Will the truth tellers please stand?
All right.
Louisa was indeed telling the truth, and Beverly was bluffing. Okay, Louisa, please explain your answer.
Sure. There are several ways to solve this problem. Okay, here's one. The 5 players are a total of 10 inches over 50 inches tall. If you could distribute that 10 inches evenly, each would get 2 inches. So, if all the Minnesota Munchkins were the same height, each would be 52 inches tall. And that's the average height.
Did that help you understand averages any better, Bernie from Bismarck?
Yes, it did. But Beverly was a little bit right.
Say what?
Well, the average height of the team had to be somewhere between the tallest person and the shortest person on the team.
Absolutely right, Bernie. But it doesn't have to be exactly in the middle of the two, and usually isn't.
Quite.
Anything else?
Yes. I'd just like to iterate that
I still don't like donuts. What do you eat in the morning, Bernie?
Cinnamon toast. It's yummy.
Why don't you hang up, Bernie, in case someone else in North Dakota wants to use the phone?
Here's another sketch about averages.
The power and the freedom of mathematics is a flaming sword. It shall be our duty to use it justly. Hold it high, guard it well. Math Court, where common sense prevails. Math Court, with the Honorable Judge Sandra Day O'Crater presiding.
Order! Order! Why do you cause such a commotion in my courtroom? This goes on and on and on. I just can't see it. I'll clear the courtroom today. And on a clear day, you can see Claire Trevor. Mr. District Attorney, why are you wearing that amusing tie?
Oh, tonight I am going to a formal Western gala.
Ah, necktie party, eh? I've had just about enough of that. Thank you. That is just enough. Are you going to try a case?
Sure, I'll try anything once.
Then do it. Who is this person in the witness box?
This person, your judgeship, is attempting to ruin our national pastime.
Television viewing?
No, Your Honor. Television is not a national pastime.
It isn't? Good. Then there's still a chance we may survive. What is our national pastime?
Baseball!
Then there's still a chance we won't survive. What's the charge?
This man is with the Cubs and claims they are the best team in the major leagues. He is their manager.
Well, he certainly looks mangier.
Oh, no, I said manager.
And I said mangier?
Let's call the whole thing off.
Why do you contend that your team is the best baseball team?
Because we are the best baseball team.
Well, hard to argue with an incisive presentation like that. Next case.
Oh, just one moment, Your Eminent One. I happen to have played baseball in my youth.
Oh?
Oh, yes, indeed. For years, I pranced around the initial sack.
You took ballet.
No, I played first base.
I thought who was on first?
Hey, don't start. Bailiff, if you would be so kind. Thank you, Bailiff. The manager says the Cubs are best. The Cubs have played their arch rivals, the Rubs, 5 times. They have scored only 10 runs in those 5 games and averaged but 2 runs per game.
Pretty weak-hitting bunch of Bruins, if you ask me.
Yes, Your Honorable One. Now, take a look at the Rubs.
Ah, there's the Rubs.
Yes. The judge will long note but little remember that the Rubs have scored 20 runs in 5 games against the Cubs and averaged 4 runs per game. Twice as many as this fellow's team. The prosecution rests.
Oh, is the itty-bitty prosecution too pooped to prattle?
Oh, no, I simply meant that I am finished.
Truth be known, you were finished years ago.
All right, Mangier, have you got a case to make?
Sure. I never say die.
And I never say anti-disestablishmentarianism, but I still don't get invited to the really good parties.
I don't see that you have a case to make, Mangier. It seems pretty clear that the Rubs are better than the Cubs. They score more runs and average more runs.
But, Your Honor, those figures are deceiving. We are the better team.
Watch him, Your Honor. He's trying to escape.
Now, take it easy, take it easy. I merely want to make my case. Now, in the first game we played, we won it. 1-0.
Pitcher's duel.
They do? I thought they threw baseball.
Oh, please. We prevailed in the second game also, this time 2-1. We won the third game 3-2. Now, the fourth game, well, it was a blowout, and we lost 14-0. But in the fifth and final game, we won again, this time 4-3.
So you're telling this court
that even though the Rubs scored more runs and averaged more runs than the Cubs won 4 out of 5 games. You see that? Averages can be deceiving. You gotta think. Use your noodle. Puzzle it out.
Mangier, you are absolutely right. The Cubs are better than the Rubs. Case dismissed. You didn't have tenure, I'd dismiss you, too.
Hey, can I go now, Your Honor? I don't want to be late for the game.
Yes, but only if you
take me out to the ball game.
Take me out to the crowd.
And so, once again, justice and baseball have prevailed in Math Court.
You know, you are a real foul ball.
Hey, averages can be misleading, huh, Maria?
Sometimes. For example, what if the Rubs had spaced out their runs better?
What do you mean, Maria?
Well, look at their third and fourth games. They scored 2 runs and then 14. What if those 16 runs had been spread out evenly between the 2 games?
Good point, good point. They would have got 8 in each game and won them both. 8-3 and 8-0.
Yes, and what if they had spread all 20 runs evenly over the 5 games?
Yikes! They would have had 4 runs in each game and won 4 and gone into extra frames in the 5th.
Could the Rubs have won all 5 games and still averaged 4 runs per game?
I don't think so. They're chokers.
I do. Suppose they had scored 2 runs in the first game. They would have won 2-1.
Yeah.
And then suppose they got 4 runs in each of the next 3 games.
And suppose they got 6 runs in the last game. They would have won that also.
But when you add up the total number of runs,
you'll still get 20, so the average is still 4.
So the Rubs could have won all the games and still averaged 4 runs.
Yeah. But could they have averaged 4 runs and lost all 5 games?
That's something to ponder. Join us again on Math Talk. Buster, what are you doing?
Pondering.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG TV, Binghamton.
Hello, I'm Maria Lopez, and
I'm Buster the Parrot, and
this is Math Talk. What mathematics shall we talk about today, Buster?
Something truly fascinating.
Okay.
Incredibly intelligent.
Great.
Mysteriously complex.
What part of mathematics might that be?
Not math, me.
I think you're getting too big for your feathers.
I'll have them let out.
Math call. Hello, you're on Math Talk.
I am glad I have caught you at home. How would you like to be the first in your neighborhood to own whole wheat encyclopedias?
Murray, I think it's one of those telemarketing guys.
Yes, you heard me right. A set of encyclopedias made out of whole wheat bread.
I think you have the wrong number.
It's a tape recording, Maria.
After you use the encyclopedia for research, you simply tear out the pages and eat them.
I'm taking another call.
I have torn the word parrot from the P volume.
Hello, Sandy from Sandusky. You're on Math Talk. Do you have a math problem?
I live across the street from Dirk Niblick and Wallace C. Beasley and George Frankley.
That's not a math problem, it's a location problem.
Last week, Mr. Beasley gave a party.
So far, I don't see a math problem.
Well, I made a movie of his preparations for it and sent it to you. I didn't realize how much math people use in their everyday lives. Did you get my tape?
Yes, we did, Sandy from Sandusky, and we'd love to see it, wouldn't we, Buster?
I sneak previewed it, and I think it could win a big award.
Oh, an Oscar?
Bigger. A Buster.
Roll 'em.
Here we have Mr. Beasley talking to a door-to-door saleswoman.
You say you're selling hot dogs and buns door to door?
That's right. Millie's, Weenies, and Rolls.
Well, this is the most fortunate stroke of plot line because I just happen to be hosting a cookout tomorrow.
Well, that's good. Now, how many people will you be serving?
17.
A fine number, if I may say so.
Oh, well, go ahead. I wouldn't let it be said that I'm the type of individual who would deprive a woman of saying a fine number.
Millie's, Weenies come 12 to a package. The hot dog rolls come 8 to a package.
I understand fully.
Now, if you buy 1 package of hot dogs and 1 package of rolls, you will have 4 hot dogs without rolls.
I'll be the laughing stock of the social world. Well, what if I buy 2 packages of hot dog rolls?
2 packages will give you 16 rolls.
But I've only got 12 hot dogs. I'm short.
Now, what if you buy a 2nd package of hot dogs?
12 to a pack? That would give me 24 hot dogs.
But you've only got 16 buns.
Great Scott, I may have to cancel the party.
No, sir. Now listen, what we have to do is find the common multiple of these 2 numbers so that they come out even. An equal number of hot dogs and hot dog buns. Do you know how we do that?
Do I look like a man who knows how to do that?
No, you don't.
No, I don't.
To make sure we have the same number of buns and wieners, we multiply the 2 numbers together. Watch. 8 packs of wieners, 12 to a pack. That's 12 times 8, or 96 wieners. 12 packs of rolls, 8 to a pack. That's 12 times 8, or 96 rolls. Wieners and rolls come out even. None left over.
Thank you for entering my life. The party will be a dilly.
Here's your bill, and I'll bring the comestibles by in 38 feet and 10 frames.
Swell. I'm one happy host, and I think I'll tell Dirk Niblick all about my joy.
Tell me about the math and the food.
Well, the hot dogs are packaged in 12s, and the rolls are packaged in 8s.
So you wanted to make sure the 2 came out even, right?
Uh-huh. So Millie, president of Millie's Weenies, showed me how to do that. We multiplied the 2 numbers together to find a common multiple. It's 96.
How many guests are you having?
Well, now that you've conned your way onto the A-list, 18.
You have 96 hot dogs for 18 people.
That does seem like a lot, doesn't it?
Well, I think the hot dog salesman has sold you a plethora of food.
No, just high sodium, high cholesterol.
Well, look here, neighbor Beasley. You should be looking for the lowest common multiple.
Well, I'll be a son of a sea cook. Dirk has pointed out yet another mathematical fact. I must admit that I don't see it, but perhaps you can if you use your noodle. Find out the smallest number of buns and hot dogs Mr. Beasley could buy if he wants the same number of each. I'll be back pretty quick, just as soon as I take the trash out.
Isn't that amazing? He used stuff I learned in school to plan his party.
Yes, he found a multiple of 8.
For the packages of hot dog buns.
And of 12.
For the hot dogs.
And he chose 96 because it was a multiple that 8 and 12 have in common.
Yes, but I thought 96, that's an awful lot of food. And I was afraid there would be an awful lot of waste.
Tisk, tisk. Waste not, want not.
So what happened?
I told Mr. B to talk to Dirk Niblick. Watch what happened.
Have you pondered the problem? Did you solve it? I didn't, but I didn't because I knew I could count on you. Let's rejoin the fellows.
Have you found the lowest common multiple, Mr. Beasley?
Is the lowest one the one that's beneath contempt?
How about 0? 0 times 8 equals 0, and 0 times 12 equals 0.
0, of course. 0 is a multiple of 8 and 12. 0 hot dogs will save me a lot of money.
But your guests will be hungry.
So let them bring a sandwich from home.
Now, here's a way to find the common multiples of 8 and 12.
What's that?
The multiples of 8. 0 times 8 is 0. 1 times 8 is 8. 2 times 8 is 16, and so on. Now, look here. This is a list of the multiples of 12.
As much as I like watching you make lists, Lieutenant.
Now, wait just a darn minute. I'm trying to show you how to use mathematics to save money. I ask you this, what numbers are on both lists?
Well, there's the fabled 96.
Yes, but...
Yes, but what?
Yes, but are there others?
The lowest is the dreaded 0.
But the guests will be hungry.
Yes. Well, there's 72, common to both lists.
Right.
48 and 24. The lowest common multiple is 24.
That's right. 24 is the smallest number on both lists.
That means I should buy 2 packages of hot dogs, 12 to a pack, and 3 packages of buns, 8 to a pack. 2 times 12 is 24, and 3 times 8 is 24. I'll save a bloody fortune.
So by choosing the least common multiple, or the lowest or smallest one, Mr. Beasley saved a bundle of bucks.
Yeah, but if he chose the highest common multiple, his guests would be swimming in hot dogs.
Buster, there is no highest common multiple. Look at this. These are the multiples of 8 and 12. They go on forever.
Do we have to watch them forever? I'm getting dizzy.
Me too.
Okay. Was it a good party, Sandy?
It was okay until Lieutenant Niblick began doing impressions of Roman numerals.
Sometimes I do those at parties.
You impersonate Roman numerals?
Yeah, usually just before they kick me out.
Hey, do you guys have anything else you can show about common multiples?
Yes. Here's a sketch from Square One TV about common multiples and a party and hors d'oeuvres.
What's hors d'oeuvres?
Canapes.
Say what?
Caviar on toast points. Finger sandwiches.
You're putting me on. Hors d'oeuvres are sandwiches made out of fingers?
Hors d'oeuvres are snacks, Buster.
Aha! Buster wants a cracker. Buster wants a cracker.
Oh, dear. Whatever will I do?
Honey, I'm home. Oh, now what are you doing? Mwah. Shouldn't you be getting ready for the party?
Well, I am, dear. I'm just trying to figure out how many hors d'oeuvres to serve tonight. I want to make sure that each guest gets an equal amount with no leftovers.
Huh. Everybody gets an equal amount. Oh, I've got it. All we have to do is figure out the number of guests that are coming to the party and then multiply that number times the number...
But we're not sure how many are coming. We may get 12, 16, or 24. Not sure.
Really? Well, we've got the strangest friends. Well, never you mind. I'm gonna get a piece of paper and we'll figure out exactly how much food we need to give 12, 16, or 24 people equal amounts of food with none left over. How's that, honey? Joan? Joan, you're not thinking of calling...
Yes, common multiple man. Years ago, while working for a midtown mathematical conglomerate known simply as Math and Brew, an accountant named Norman Redundant was involved in a freak accident.
Oh!
Norman was transformed from this to this. Common multiple man. He was endowed with the ability to determine instantly the common multiples of any 2 or more whole numbers.
I am a superhero
In a dumb suit.
with a pretty nutty superpower. Well, you go with what you've got. I'm sorry I took so long.
Can't you fly or anything?
I couldn't even get a cab. But have no fear, for Common Multiple Man is here.
Yes, I see. All right, well, we're having a party. And we are going to have 12, 16, or 24 guests. We're not sure.
Uh-huh.
But we do know that we want each guest to get the same amount of hors d'oeuvres with none left over and...
48. You need either 48, 96, or 240.
How did he do that? Super.
Yes, well, it's something which
Dear, it's very, very easy. Look, all you have to do is take the possible number of guests, 12, 16, or 24. You find their multiples, then you find the common multiple.
Absolutely. That's the first step.
For example, here's one. 48. All right, and here's another one. 96. Now, you pick one of the common multiples, you buy that amount of hors d'oeuvres, and everyone will get an equal share.
Correct. But the
For
next...
example, let's say you picked 48, and 16 guests showed up. Each guest would get 3 hors d'oeuvres. If 24 guests showed up, each guest would get 2 hors d'oeuvres. And if 12 guests showed up, each one would get 4 hors d'oeuvres. You see?
Yes, absolutely. But most
All
people would...
because of common multiples. Equal shares, none left over.
Yes, but when I did it instantly and with a funny sound. And you did not.
Fine. That's fascinating. Excellent. Very strange costume.
Hey, it won't come off, okay?
Well, thanks for stopping by, Common Multiple Man. We'd love to have you stay, but we've already solved the hors d'oeuvres problem, and...
I can find a common multiple for any set of numbers. It's a gift.
I'm sure you can. Well,
You see,
bye.
most people cannot do this. It's
Joan, we could have done this ourselves. Anyone can.
Yes, anyone can do it, but you see,
He
when I
knows,
do
he
it...
knows. Well, bye.
Oh, great.
Join us soon
Hey,
for the
you
further
guys.
adventures of
My cape. My
Common
cape.
Multiple
Open
Man.
the door. You guys. Is anybody there?
I noticed something wrong in that sketch. They didn't mention 0. 0 is also a common multiple of 12, 16, and 24.
That's true, it is. But with 0 snacks, the guests might starve.
So, who invited him in the first place?
Well, I get it now. Thanks for having me on Math Talk.
Thank you for showing us your party tape.
And tell Wallace C. Beasley hello for me.
You know Wallace C. Beasley?
I used to date his mynah bird
Oh.
in the old days.
See you next time on Math Talk.
He was a fine, fine feathered friend.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
WSKG TV, Binghamton.
Hi, I'm Maria Lopez.
And I'm Buster the Parrot.
Welcome to Square One TV's Math Talk. Know what we're going to talk about today, Buster?
About 15 minutes.
Be serious.
I tried being serious once, but everybody thought I was an owl.
Buster,
Besides, after the show, I'm going to meet Sylvia.
you really like Sylvia a bunch, don't you, Buster?
Maria, I'd like to give her 1,000,000 hugs.
And that's what we're going to talk about today.
How much I like Sylvia?
No, 1,000,000 and other large numbers.
I'd rather talk about Sylvia.
Later. Right now, take a look at this sketch. It shows how you can get from very small numbers to very large numbers very fast.
And now please welcome the guy who's numero uno on the math comedy circuit, David Numberman!
Oh! Thank you. Woo! Paul, we finally get to meet the billionaire waitress from Illinois. Oh, yes! We are going to have big fun today. Fun squared, you might say, right, Paul?
You said it, Dave.
Yeah?
Fun so big, I don't even think this studio can contain it.
I don't think so either. It's sort of like the Blob. Fun that just sort of keeps on growing and growing until it spills out onto the street and just takes over the whole country. Is that what you meant, Paul?
Not really, Dave.
Not really. You're not suggesting that meeting the billionaire waitress from Illinois isn't going to be fun, are you, Paul?
No.
No, good, because it's the main part of our show, Paul, and if that's not great and fun, we're in big trouble.
Big trouble.
Big trouble, yes. Well, which will it be? Big fun or big trouble? Let's find out. Please welcome Gloria Johnson, the billionaire waitress from Illinois! So let me get this straight. You're a waitress by profession.
Well, I was, but I'm retired now.
Oh, I see. And how long was your career as waitress?
Just a month.
A month?
Yeah.
And you claim to have become a billionaire in that amount of time?
Yeah, that's right, Dave.
That sound a bit fishy, Paul?
A little fishy, a little hard to fathom.
Yeah, I mean, if you said you were a plumber, you know, I might believe you, but that sounds a mite, far-fetched. Well, what's the secret to your success?
It's no big deal, Dave. See, there's a job opening for a waitress at Chubby's Diner in Manhattan.
Chubby's Diner?
Yeah, Chubby's the owner. He calls everybody else Chubby, too. Hey, Chubby, how you been? Chubby,
Wait,
was in here looking...
Chubby's Diner in Manhattan?
Manhattan, Illinois.
Oh, Manhattan, Illinois. Okay, all right, so, go on.
So Chubby offers me this temp job as a waitress.
Well, why temp?
Oh, because the regular waitress, Francine, had to take a month's leave of absence.
Oh, I see. So Chubby offered you Francine's
Right.
job.
And he offered to pay me one measly $1 a day plus tips. Now, I had no previous waitress experience, but I knew this was a crummy deal, so I said, no way, Jose Chubby. But I will consider your kind offer if you start me at $1 and then double my pay each day. So Chubby goes $1 for the first day, $2 for the second day, then 4, then 8, then 16, etc. Sounds okay to me. It's only a month. And that was that. And here I am, a billionaire.
Just from doubling your daily wage?
Yeah, that's right, Dave. Hey, work it out for yourself.
Well, you bet I will. Time for the number cam. First day, $1. Double that. And double that again. And again. And again. There we go. 5th day, 6th day, 7th day. Now, no days off.
Nah. Now, those numbers grow pretty fast when you keep doubling, don't they?
Look at
It's called exponential growth, Dave.
Right, exponential growth, Dave.
Wow, that is amazing. Look at that. Whoa, okay, 28th day, 29th day, 30th day, $536,870,912. That's over $500 million. And that doesn't include tips.
Right.
Wow, so technically you're a multi-millionaire, not a billionaire.
Hey, it was August, Dave. 31 days. Double it again, you're over $1 billion.
Oh.
Right, and remember, that's just my last day's pay.
You're absolutely
My total
right.
for the whole month is a lot more than that.
Wow, that's incredible. Well, Gloria, this is truly a heartwarming story of exponential growth in action. So, what, with all this money, you probably got yourself a nice little piece of property somewhere? Yeah, sure, yeah.
Take a look.
Okay. That's very funny, Gloria. Yes, indeed. Yes, very funny, Gloria. Cal, can we get a shot of this? Yeah. This is my place in Connecticut.
Dave, it's my place. Connecticut.
It's very funny, Gloria. It's not for sale, Gloria.
It's a done deal, Dave. Talk to your lawyer.
Yes, well, we'll be right back right after this word from our sponsor, if we still have one. Now, Gloria, can I just ask you one quick question?
We have a call from Bill in Billings, Montana. Welcome to Math Talk, Bill.
Thanks, Maria. It seems to me that Chubby was pretty dumb. I mean, by the 8th day, he was paying Gloria $128 per day. For an 8-hour day, that's $16 an hour, a pretty high wage. He should have thought that through.
Yes, but it sure shows you what exponential growth can do.
Besides, where did he ever get the $1 billion to pay her?
Saved his tips as a busboy?
That is a large amount of money.
Yeah, even I, Buster the TV superstar, don't have that much loot yet. Wait till I get my own series.
Hey, what if Chubby had agreed to pay Gloria less than twice the previous day's salary?
Yeah, like 1 1/2 times.
Uh-huh, or even less.
Cheapskate, cheapskate.
Buster, here's something else about really big numbers.
So, infinity is the largest number?
No. What the song sings is that there is no largest number. No matter what number you've got, there's always a larger one.
Yeah, just add 1 to it. Uh-oh.
What?
I wonder if I should reconsider Sylvia and the 1 million hugs.
I have trouble getting my mind around numbers that are so large.
Me too. But here's another sketch about large numbers that might help.
Hi! Facts Headful, was watching this soap opera the other day, back there on... Shh. Don't tell. On another channel. And they had this scene where the guy and the girl are having this romantic dinner. And the guy says to the girl, Tiffany, you look beautiful tonight. And she says to him,
Oh, Todd, how can I ever thank you for saving my mother's life by using your superior skills in brain surgery? Wow. And how can I ever thank you for saving my brother's turnip ranch by using your superior skills in turnip husbandry? That's weird.
Forget turnip husbandry, Tiffany. Forget everything. Just let me be your husband.
Oh, Todd, 5.3 billion people in the world, and I was lucky enough to find you.
Yeah. Talk about mush. Except it got me thinking. I checked out what she said. There are about 5.3 billion of you Earthling-type humanoids in the world. Whoa, 5.3 billion people. Woo! That's a seriously big number. You want to know how big? Well, if you decided to line up all the people in the world and have them count off here, here,
Present here.
yo,
Ici, aquí.
here, it would take more than 200 years of non-stop day and night round-the-clock counting to get through 5.3 billion. But you know what? The world population isn't going to stand still at 5.3 billion. No way! It keeps growing. Say at the current rate of growth, the world will double its total population every 40 years. Amazing. If I look what that means. If I am the world population now, see? I'm the world population, 5.3 billion. And I keep growing at the rate the population is growing now, then, ooh, this is how big the world population will be in 40 years. Double. 10.6. Whoa! And then in 80 years, whoa! And in 120 years, whoa! You see how huge things can get? If you double them and then double the double and then double the double, you just doubled and. Whew. Phew. And I thought 5.3 billion was a lot. You know, I was thinking, you 5.3 billion humanoids have birthdays, right? So I got to wondering, how many birthdays there might be every day? Let me see, 5.3 billion divided by 365 days in a year comes to... Yikes! 14.5 million birthdays each day, on average. Think of all the cakes and candles and of all the wishes. Happy birthday to you. Happy birthday to you. Happy birthday, dear. 14 million humanoids. Happy birthday to you. Make a wish, everybody.
Those aren't just large numbers, they're gigantic.
Yeah, but you know another amazing thing was how long it would take to count the 5.3 billion people. 200 years. How fast did they count?
I worked it out. Just under 1 second per person, 24 hours a day, 365 days a year.
I'd hate to have that job.
Plenty of security.
But you'd be so dull, you'd probably never get invited to parties.
I don't get invited to parties now.
Ah, but Buster, you have Sylvia. Just think, of all the parrots in the world, Sylvia chose you.
I wonder how long it would take to count all the parrots in the world.
Not long. Just count their legs and divide by 2.
That would take twice as long, which is more time than we have left. Thanks for your call, Bill. We'll see you all next time on Math Talk.
One more call, Maria. I'll take it. Hello, you're on Math Talk.
This is Sylvia. I watched the show today, Buster. Why were you going to give me 1 million bugs?
I said hugs, not bugs, hugs.
Why a measly million?
Okay. How about 1 billion? That's 1,000 million.
How about a trillion? That's 1,000 billion.
You're on. And I'll even throw in an extra million for every month that has an R in it.
Buster, you are truly a fine feathered friend.
Yeah.
Square One TV Math Talk is a production of the Children's Television Workshop. Funding for Square One TV Math Talk was provided by the National Science Foundation, the Corporation for Public Broadcasting, and by annual financial support from viewers like you. To purchase video cassettes or a Math Talk Teacher's Guide, please write to this address.
This is TBS.
WSKG-TV, Binghamton.
Good evening, I'm Jim Lara. On the NewsHour tonight, McCain-Feingold goes down in the Senate with excerpts and reaction from Senators McCain, Feingold, McConnell, and Nichols. Coverage of former White House aide Harold Ickey's appearance before the Thompson Committee, a debate about Israel's decision to assassinate a Palestinian leader, and a Jeffrey Kay report on the coming of El Nino. It all follows our summary of the news this Tuesday.
Brought to you in part by ADM. Feeding the world is the biggest challenge of the new century.